Trigonometry, simplifying expressions, proving identities, solving equations involving sec, cosec and cot theta. This is similar to some of the work you covered in C2, but there's just lots more possibilities now. As in C2, you must practice as much as possible in order to get a feel for what to do and when to do it. Simplify sine theta, cot theta, sec theta. Well, let's rewrite these things in terms of other ratios. Cot theta, if you remember, is 1 over tan, although we also told you in the previous video that tan is sine over cos, so cot is cos over sine. Tan is sine over cos, cot is cos over sine, so we can rewrite cot theta as cos theta over sine theta. Sec theta, well, sec is 1 over cos theta, so now things happen. If we group it as a single fraction, we have sine theta cos theta over sine theta cos theta, and it's cancelling Armageddon. It's 1. Sine theta cos theta times sec theta plus cosec theta. My general advice in all of these questions is just to do things, and eventually the right path will become clear, even if you're not too sure what to do at the start. In this case, if we rewrite the part in the brackets, it's 1 over cos theta plus 1 over sine theta. It's probably a good idea then to get some sort of common denominator going on. So sine theta over sine theta cos theta plus cos theta over sine theta cos theta. And then, because we've got a common denominator, we can now group the second side. We can add it up. So it's sine theta plus cos theta over sine theta cos theta inside the bracket, and we've still got sine theta cos theta lurking outside of the bracket. If we multiply the part on the top by the part outside, we end up with that. Then we can cancel the common factors, the sine theta cos theta on the top and the bottom, to be left with sine theta plus cos theta. And quite frankly, we aren't going to get much more simple than that. Quite often in exams, these questions are show that questions. It is of vital importance in show that questions that you show sufficient lines of working out to convince the examiner that you know what you're doing. I mark C3 papers, and so I see the sorts of magic tricks that students sometimes try to pull, where they know what the answer should be, so it magically becomes the answer 3/4 of the way through. Make sure you show all the lines of working out, and then the examiner can easily check you've done what you need to do to get the marks. So show that cot theta cosec theta over sec squared theta plus cosec squared theta is the same as cos cubed theta. Don't worry about the cos cubed, that will pop out at the end, hopefully, if we do it right. Cot theta over cosec theta over sec squared theta plus cosec squared theta, where the numerator is cot theta cosec theta. Let's really split it down. If we rewrite cot theta, that's 1 over tan, but that's the same as cos over sine. And if we rewrite cosec theta, that's 1 over sine. So we've got cos theta in the numerator and sine squared theta in the denominator. That's the numerator, sort of tidied up a bit. The denominator, sec squared theta plus cosec squared theta, well, sec squared is 1 over cos, so that's 1 over cos squared theta. Cosec squared theta is 1 over sine squared theta. we don't want to fall into a trap here. We need to speak, because you might fall into the trap of thinking, sine squared plus cos squared. We can't do that because in the denominators we need a common denominator. So we times it by the opposite denominator, sine squared over cos squared squared sine squared plus cos squared over cos squared sine squared. We can then add it up to be sine squared theta plus cos squared theta over cos squared theta sine squared theta. And then we can realise, aha, the numerator is sine squared plus cos squared, so that's the same as 1. It's an extension of Pythagoras, so it's 1 over cos squared theta sine squared theta. Now if we put those together, we've got the numerator, which is now cos theta over sine squared theta, divided by our denominator, 1 over cos squared theta sine squared theta. There are two separate parts. It's just a fraction division, and if you remember that when you divide fractions, you switch it over and times. So it's cos theta over sine squared theta divided by 1 over cos squared theta sine squared theta, which is the same as cos theta over sine squared theta times cos squared theta sine squared theta over 1. All's looking good in the world now, because if we group it up, we've got cos cubed theta sine squared theta in the numerator and sine squared theta in the denominator, and then the sine squared thetas cancel off and we're left with cos cubed theta, which was what we wanted in the first place. So we have shown that. In an exam you need to show all of that working out in order to guarantee the mark. It has to be obvious to the examiner the steps that you followed to get from the original to the answer. We can solve equations as well by rearranging them in terms of sine, cos or tan, and then using the respective graphs. So this is again using skills we used in C2, but now with some extra excitement. Solve the equation sec theta is equal to minus 2.5 in the range 0 to 360. Sec theta is minus 2.5, whereas sec is 1 over cos theta. If we rearrange that, we can get that cos theta is 1 over minus 2.5, or cos theta is minus 0.4. So we've rearranged it. Once we've rearranged it, we can now solve that. We inverse cos. The inverse cos of minus 0.4 is 113.6 according to our calculator. That's one answer in the range. We can draw a quick cos graph. We can see that 113.6 is 23.6 above 90, so there's another answer 23.6 below 270. That will also be a solution. Solve the equation cot2 theta is 0.6 in the range 0 to 360. It's a function of theta, so we need the new range. So instead of being 0 to 360, it's now 0 to 720. So we're looking for answers in the range 0 to 720. Cot is 1 over tan. So if cot 2 theta is 0.6, that means that tan 2 theta is 1 over 0.6. If we inverse tan that, 2 theta is 59.04 degrees using the calculator. And then we can draw our tan graph and find if we got one answer at 59.04 degrees, then there's another answer at 239.04 degrees, 180 plus 59.04. And there's also answers at 419, because tan repeats every 180, and 599.04. Those are all of our answers that are in the range between 0 and 720. So now if we divide all of those by 2, we get theta is 29.5, 120, 210 and 300 degrees. Remember though, when it's a function of theta, we need a new range, and we need to find all the solutions in that range, and only at the end undo the function of theta to get the actual answers. Solve the equation 3 cosec theta is equal to 2 sec theta in the range 0 to 360. Well, let's tidy it up. Cosec is 1 over sine, so it's 3 over sine theta. Sec is 1 over cos, so 2 sec theta is 2 over cos theta. Not keen on those denominators, so let's cross multiply to get 3 cos theta equals 2 sine theta. Well, we're getting somewhere now. We should probably divide, because we seem to have 2 different ratios in this question. It would be much easier with one ratio. If we divide by cos theta, we get that 3 is 2 sine theta over cos theta. Then we can divide by 2 to say 1.5 is sine theta over cos theta. And then we can say, hang on a second, sine theta over cos theta, that's tan theta. So tan theta is 1.5. Now we can inverse tan that to say theta must therefore be 56.31 degrees. We know that tan repeats every 180 degrees, so therefore we also know there's another solution at 236.31 degrees. Given that tan A is a minus 5 over 12, and A is obtuse, find the exact value of sec A. Tan A is the opposite over the adjacent. If we draw a triangle, then must be 5 over 12 is tan A. Okay, one of them is minus, we can live with that because it's an obtuse angle. We're not going to worry about the minus sign. We'll worry about the minus sign at some other point in the day, but at the minute it doesn't matter. If we can use Pythagoras to work out the missing side, it's a 5, 12, 13 triangle. We should know that from our Pythagoras theorem. So cos theta is the adjacent over the hypotenuse. So if we now substitute those in, cos theta is 12 over 13. A is obtuse, so it's in the second quadrant. So if A is obtuse in the second quadrant, that bit there of the cos graph, we can see that cos must be negative. So that means that cos theta must be minus 12 over 13. We can use the idea of which quadrant we're in and whether the graph is positive or negative to find out about the minus sign. So we don't worry about it at the start, we worry about it at the end. And then to get sec theta, which was the original question, sec is 1 over cos, so it's minus 13 over 12. Given that tan A is minus 5 over 12 and A is obtuse, find the exact value of cosec A. So we've got the same little triangle, if we're still ignoring the minus, we know that sine, because it's cosec now, we know that sine is opposite over hypotenuse. So it's 5 over 13. It's obtuse, so we're still in the second quadrant. Sine is positive in the second quadrant. So that means that sine theta really is 5 over 13. Cosec theta therefore is 13 over 5. 1 over sine. The reciprocal. You also need to know and use the following identities. 1 plus tan squared is equal to sec squared. 1 plus cot squared is equal to cosec squared. And you might be able to show where these have come from, but neither are terribly difficult to show. because they both come from sine squared plus cos squared is equal to 1. If we divide everything by cos squared, we get sine squared over cos squared plus cos squared over cos squared equals 1 over cos squared. Well, sine squared over cos squared is the same as tan squared, cos squared over cos squared is 1, and 1 over cos squared is sec squared. So that's the first one shown. The second one, you might be able to guess, we divide everything by sine squared. So we get sine squared over sine squared plus cos squared over sine squared equals 1 over sine squared. Well, sine squared over sine squared is 1, cos squared over sine squared is cot squared, and 1 over sine squared is cosec squared. You might be asked to show those, so you should learn how to do those two proofs. Prove that cosec to the power 4 theta minus cot to the power 4 theta is 1 minus cos squared theta over 1 plus cos squared theta over 1 minus cos squared theta. These questions are nice little questions where you use the various formulas we've learned. They're all at the top of the video here, and try to rearrange it. Only worry about one of the sides, the other side will hopefully turn up on its own. So we'll invariably worry about the left hand side. So cosec power 4 theta minus cot to the power 4 theta. Well, okay, let's rewrite a few things and see what happens. This is my best advice. If it looks like you're going down a blind avenue, you can always restart, but just do things. Cosec. Right, so we've got a difference of two squares going on here. We've got cosec squared theta plus cot squared theta times cosec squared theta minus cot squared theta. It's very, very useful to be able to recognise difference of two squares even when you've got things that aren't squares. Once we've managed to factorise in a double bracket, things are already looking a bit perkier because we can replace a few things now. Cosec squared, we can replace with 1 plus cot squared. So we got 1 plus cot squared minus cot squared. That makes that second bracket just 1, so that makes life a bit easier. So we've got cosec squared plus cot squared. Well, let's do the same, just replace cosec squared with 1 over sine squared. And let's replace cot squared with cos squared over sine squared. Now we've got a common denominator. We can group into one fraction, 1 plus cos squared over sine squared. The bottom we can rearrange to say that sine squared is 1 minus cos squared, and then, hey presto, we've got the answer. It's not entirely easy, these questions. They take a lot of practice because you could do the wrong thing very easily. But when I say the wrong thing, they're not necessarily the wrong thing. You'll still get to the right answer just by a very, very long route. So sometimes there's more than one way to skin this particular banana. So there are other ways you could have got to the same place. But invariably, if you look to factorise, if you're looking to replace the identities with equivalent ones, if you're looking to trying to get common denominators and group them into one fraction, those are the sorts of ideas that allow you to change from one expression to the other expression. Prove that sec squared minus cos squared is sine squared 1 plus sec squared. Okay, in this case, let's look at the right hand side, but that's the side that looks a bit more complicated. We've got sine squared theta 1 plus sec squared theta. We can multiply it out, so we get sine squared theta plus sine squared theta sec squared theta. We can then think to ourselves, well, hang on, sec squared theta, that's the same as 1 over cos squared theta. And we can write that as a single fraction. Sine squared theta plus sine squared theta over cos squared theta. We can then replace the fraction, because sine over cos is tan, so that's tan squared theta. We can then rewrite both of those terms based on the inequalities. Sine squared plus cos squared is equal to 1. So sine squared is 1 minus cos squared theta. And tan squared plus 1 is sec squared. So tan squared is sec squared theta minus 1. Well, now you can see by doing that, we've pretty much got to the point where we want to get to, which is that sec squared minus cos squared is the same as the solution. Now obviously you could have done that from the left hand side and worked your way forward the other way. Either way would work fine in this particular question. These questions require a lot of practice and will be very slow to begin with, but the more questions you do, the faster you will get, and you'll become more aware of the techniques and the strategies that can be used to rewrite the expressions. Solve the equation 4 cosec squared theta minus 9 equals cot theta in the interval 0 to 360. A general strategy is to replace terms until they're all of the same type, cos, cot, or whatever. So 4 cosec squared minus 9, let's replace the cosec squared. 1 plus cot squared is cosec squared, so we've got 4 1 plus cot squared minus 9 is equal to cot theta. Haha! Now we've got cots. Times at the brackets, 4 plus 4 cot squared theta minus 9 is cot theta. Bit of rearranging, 4 cot squared theta minus cot theta minus 5 is equal to 0. Now we can factorise that. 4 cot theta minus 5, cot theta plus 1. So now there are two solutions, either cot theta is 5 over 4 or cot theta is equal to minus 1. If we invert it so we can use the tan graph, tan theta is 4/5 or tan theta is minus 1. Use the calculator to get the first answer, theta's 38.7. And then remember that tan theta repeats every 180 degrees, so 219 will be the next answer. And for tan theta is minus 1, that's 135 and 315.